All right, so this is functions and relations 2. I got cut off last time because I don't want them to go past 5 minutes. But in the last one, we talked about the idea of a relation versus a function, right? If something is a function, well, relation is just really a set of all ordered pairs, right? If something is a function, though, those ordered pairs would have a certain set of characteristics, like there would only be one output for every input, right? Um, so with that said, we should be able to take a look and look at different things and see whether or not something is an output. I'm sorry, something is a function or not. Before we looked at these two different versions here, the mapping, and then we looked at the tables. And in both of these, we looked at what the numbers were, and we wanted to see if each of these represented a function or a relation. This is a function, and this is a function, because if I look at each of the x values, they only go to one y value. It's clear when the mapping looks like that. When it looks like this, sometimes people get a little nervous. But look, the 2 goes to 1 and the -3 goes to 1. That's fine because 2 only goes to one number. -3 only goes to one number. It happens to be the same number, but that's okay, right? Remember, our definition was that there is one output for every input. It's not saying that it is 1 to 1. That's another phrase. It's just saying that each input is going to one output. When we looked at number 3, that was not the case. 4 went to 2, and 4 also went to 5. Well, that's a problem. It can't go to two different outputs, so that makes it a relation. It's not a function, so it's just a relation. Same thing down here with the tables. This one was fine. All of my x's were different x's in this particular set. And so right away, I should be good. There won't be any repeats. 4 won't go to two different places because 4 is only listed once. In number 5, 5 is listed twice. And so I need to pay attention to that. 5 goes to -3 and 5 goes to 2. Well, it can't go to two different y's, so that's just a relation. Let me skip down really quickly and take a look at this graph here. If I were to look at this graph, and I'll use this one, and I looked at this value right here, that's x equals 1, right? X equals 1. So looks like I can look at two different points. There's a point right here at x equals 1 and a point right here where x equals 1, let's just say, right? If this is a 1, if this is a -1, in fact, let me make this a little bit bigger so I can really get to it, right? This is -1 on the y, this is 1 on the y, this is 1 on the x. Notice that I have two different values here, one here, one here. This point right here is going to be 1, 1. This point right here is going to be 1, -1. So wait a minute, I have an input value of 1 and 1. So just like up here, if I have more than one value of x, I need to investigate to see if I have different values of y. Well, wait a minute, if I look at this, my y is 1 here and it's -1 there. So that tells you since I have more than one output for each input, that is not a function, that's just a relation. Okay, I'm not going to worry about numbers 9 and 10 right now because we need to talk about equations of lines first, and I'm not going to deal with that. But let's take a look at number 7 really quickly. Number 7, if I have a list, this thing right here is just called a bracket, a brace. It just means the set of. That's what those mean. So it's this set of ordered pairs is 2, 5, 4, -2, 3, 3, 5, 4, -2, 5. To see if it's a function or relation, I'm going to look at just the x values first. And since I see that all of those are different numbers, I'm good. That is a function. If I look at number 8, same idea. I'm looking at a 6, a -4, a 5, a 4, and a 6. Wait a minute, I repeated 6, so let me double check. 6 goes to -1 and 6 goes to 5. Those are two different things. That is not a function. It is a relation. All right. So if you were given a mapping, a table, or a set of ordered pairs, let me write that, ordered pairs, the idea is still the same, even if you have a graph. It's all the same. The idea also being, really quickly in the last 10 seconds, if I took a vertical line and I graphed it and I just slid it across this thing, if I drew a vertical line somewhere and it hit the graph in two different places, boom and boom, it is not